Good morning, everyone. I'm Amogh, and we're Team GigaBit. We're excited to introduce Socratic AI, our solution to revolutionize data science education by bridging the gap between theory and GPU-accelerated practice. We're a team of passionate computer science students skilled in AI, full-stack integration, and CUDA development. Joining me are Ajay, Debopam, Sagar, and Susrik. We built Socratic AI because we've seen firsthand how challenging it is for students to learn new technologies. Imagine this, a student late at night, stuck training their first neural network. The code runs slowly, errors appear, and they're lost, not just in writing code, but in understanding why it works. Over 65% of students drop out of data science programs not due to lack of interest, but because of the steep learning curve. Current AI tutors answer questions but don't let students truly code, experiment, or grasp how GPU acceleration works. That's where Socratic AI comes in. It's not just a chatbot, it's a complete learning environment for mastering GPU accelerated development. Socratic AI offers structured courses like CUDA Basics with guided topics, unlimited practice questions, and on demand assessments. It also has a free chat mode where students can ask anything in real time.
We've built a personalized tutoring mode that identifies gaps in students' knowledge, provides step-by-step guidance, runs CUDA-aware Python challenges, and shows live benchmarks comparing CPU and GPU performance. Socratic AI features a live code editor where students can practice CUDA coding, run their code, and instantly see performance metrics and speedups. It can clean up messy Python, explain the fixes, execute code on both CPU and GPU, and show why one performs better. Students don't just get answers, they gain true understanding. We've also integrated multiple AI models that users can switch between for flexibility and deeper insights. This figure shows our system architecture. We use a rack system to pull knowledge from public datasets and repositories, generating high-quality, CUDA-compatible code. And now, to show how it all comes together, we'd love you to watch our demo video.
Hello, everyone. Welcome to our demo of Socrates CUDA Tutor, a powerful AI tutor designed to help students and developers to learn the fundamentals of CUDA and data science. On the dashboard, you'll see sample questions that you can ask the AI. On the left sidebar, we have modules covering our introductory CUDA courses. Users can start chats under any module to dive deeper into any specific topics of interest. Let's create a chat and ask a question to our AI tutor. You can also switch between different AI models like 20.5, Mistral, DeepSeek, depending on your needs. Once you receive an answer, you'll see detailed GPU performance metrics, giving you insights in how your code runs and how to optimize it.
For those who work well with a more structured curriculum, we have a dedicated tutoring session where a student can talk to AI tutor one-to-one and have the AI tutor assess their knowledge. We have designed it in such a way that it asks us what level of understanding we have. And let's say if we are a beginner, we can just reply by saying A, by choosing an option A here for complete beginner. We also have a quick assessment questionnaire that students can answer about. We have given a simple example. I think just gonna stick with this. And it will design a more personalized learning path for us. It has given us some sample code and a quiz to review what we have learned and what it has taught us. We can go and attempt this quiz. It will give us some feedback to our answers. Later, it will ask us if we want to dive deeper. Then let's just say yes. And then it will give us some post material that is already available in the tutoring profile. Here it's given us some key takeaways on performance. And this is one of the most important features that we have implemented, and that is a coding challenge. After you have reached a considerable level of understanding, you can attempt this coding challenge where you can open a code editor, attempt these to-dos, and submit your code for review. Let's just compile this and see what happens. Although we have a bunch of to-dos to do, code has compiled and executed properly, but let's also ask AI to review it. We can ask for the correctness, and we can constantly ask for reviews, how we can improve our code. So it has given us some tips. Basically, whatever the code has listed as to-dos, it has rated those code snippets. So this is our application, Socrates AI. Thank you so much for watching. Thank you so much, everyone, for watching this video. I would like to tell you that we would like to extend the functionalities by adding like RAG metrics and automating CUDA checks in our application, and also build like learning analytics so that we can analyze how a person is learning while using our application. Thank you so much.
Minute and a half for questions and feedback.
Curious about how you measure the accuracy of your model.
Sure. So we utilize like multiple data sets to firstly like fine-tune our model using RAG, and then we also use data sets that are available online. That is like kernel bench, NVIDIA CUDA samples, and a Stanford data set for validating our result. We had this one data set called Scana AI CUDA Engineer that we have used in our RAG system, and we have used kernel bench and NVIDIA CUDA samples for evaluating the accuracy of a model. And when we did that, we achieved an accuracy of 85% with Qwen 2.5 and around like 70% with Minstrel, which was just right behind Qwen 2.5. We evaluated like multiple models using this, like the GPU utilization, their resource utilization, memory, and everything, which gets printed on the screen that user can check.
Any more questions? Okay.